Time for the final boss. Abstract classes and overloaded methods in Java. It sounds really cool. And my last couple of videos was about inheritance and interfaces, and this is like the final boss. This is the harder one. So abstract classes is like a mix between a real class and an interface. So you can do both. You can actually make an interface out of an abstract class. So let's try to look at how to define abstract classes first and how we can use them. So in my previous videos, I made this interface that I call iActable that has a method called act. Sometimes we want something like our interface to be a little more than an interface. Sometimes we want it to also have some functionality. The nice thing about pure interfaces is that we can, for example, for this car, that it can actually implement more than one interface. But if we make this into a class, and this also means abstract class, there is no way we can use more than one. So if we can do with an interface, this is almost always the best option. But let me short explain this example that I have here. So what I do is I have a list of actors in my game here, my game engine, and what my game engine does, it just runs 10 times per second and tells everyone in the game to do their thing, like move or whatever. And I should probably develop this a bit more if I want it to be a AAA game, but I'm close, so I'll keep it at this. So first, let's try to define an abstract class. So one of the things that I want to do is I already have one of these classes that is pretty special. So this class here called animal is already like a weird class. So if I have a game, I have a car doing different things, I have animal, and I could imagine that I have a wombat, I have a snake, I have a bird or something like that. They are all different, doing different things. The wombat might move slowly. The bird might be able to fly over obstacles. The wombat can eat stones. We know that already. So, and the animal is kind of like a super class that doesn't need to be in the game, because how does an animal do something if it's not a specific kind of animal? Maybe we need to know whether it can go fly or something like that. So animal, first off, when we make a class abstract, we make it impossible to instantiate it. So it becomes like a virtual class, or we can call it like, an abstract class. It's just an abstraction. It's not something that we want in our system. So if I change this into abstract, what happens is I get one problem. And that problem is I cannot instantiate it from this code that I have here. So I'm saying a animal is Steve. So basically the first thing I'm saying when I create an abstract class is that I can never have any instances of it. I cannot create a new animal. And this is sometimes something you want. You don't want the animal in the game. You could also imagine if you're doing like RPG games, you could have something called a class called class. Now it gets a bit confusing. And these classes can then be, warrior or droid or whatever they are called, all of these classes, and they can inherit from that. But you cannot have a class that's not anything that's just a class. It doesn't make sense in the game. They need to be something, maybe to generate the correct image, maybe to see what they can do in the game. They can't just be like a generic like something. You could say the same about car. Maybe it's also too generic. Maybe if it was a game like Grand Theft Auto, you want it to be like a specific car or something like that. It can't just be a car, because is it like a truck? It will move differently than a car. So maybe car, you want that to be a super abstract class or something, because cars may have a lot of things in common, but the things they have in common doesn't make up a car in itself. I don't know if that makes sense, but that's how I think of it. So now that I cannot create any animals, Steve is kind of gone. So let's make another animal in here, like let's make a bird. And then we want to say that bird extends animal. And if bird extends animal, we need a matching constructor. That's just a requirement. And then I'm going to change my code here to bird. Let's call it B, which is a new bird, and B here. So now we have a bird and a wombat and a car, and they are all in the game because they are all actable. And the bird gained the actable trait from the animal, which is now an abstract class. The animal implements iActable, and it also have an act method. The cool thing about the animal being an abstract class, because I cannot instantiate it, I can actually remove the act method in here. So I can remove the act method and say, animals should not act. Animals should just tell others to act. So this means that now the wombat needs to have an act method, otherwise it cannot extend animal, but also the bird needs to have an act method. So I'll put an act method in here, and I'll also put an act method into the wombat. And I cannot access the name and location here, so that's pretty annoying. So if I go into my abstract class animal, I can see these are private. And I think we can make them protected so that the subclasses can use them, all of them, right? So that's it. So now they are here. So now they kind of do acting out, let's say, wombat stuff, maybe eating stone. And we can make the bird do something like sharpening beak, something like that. It's a violent bird. So now if I run this, we will see that it will work like that. So I'll stop the game engine here. We can see I am Steve, sharpening beak. I am Alan, acting out wombat stuff because Alan is a wombat, right? Maybe he's eating stone. And then the car is just acting, like roaming around or whatever. So now our little game engine can still run these things. And we have our animal, which is an abstract class that implements an interface, but it doesn't say how to use the interface. So what we can do in abstract classes is we can define abstract methods. And one of the abstract methods is coming from actable. We can also say all animals need to have a way to eat, for example, which is not in the iActable interface. So we can say public void eat, and then gain whatever it gains, or it could be food or whatever, and then health, not minus equals plus equals gain. So we kind of gain some food from that value for that food that we eat, right? So we get some extra health for eating food. We want all our animals to be able to do that. If I put it on the abstract class here, I also define the behavior here. But what if animals eat differently, right? So what if wombat will not get as much as a bird from something, like the value, let's say it's 5 kilos of food, like a bird on like 50-gram bird, well that would be a lot of food for the bird, so its health should go up more. So how do I define that behavior? Animal cannot know about the subclasses, so he can't like check if it's a bird do this or if it's a wombat do that. For that we can use the polymorphism. So if I remove that part and simply just does like that, and then say it is public and it is abstract, So again, animal takes no responsibility. It just says this method needs to be carried out by the subclasses. So now bird needs to be able to eat. So let me just go implement method. And I don't know what. I thought I copied it. Let me just copy it here. So now it overrides it from the animal class, and it says health plus equals value multiplied by 50 or something like that, right? So it will be 50 times more whatever value it has, the food that it gets. Whereas the wombat, it just, you know, let's go and implement the method. So we could check that if it's eaten stone, enough stone in the past it could do, or just do something or simple like set health plus equals value multiplied by 0.5 or something like that. So now it's different for each animal. If the bird eats, it gets a lot of value per food that it eats, and if the wombat eats, it gets a lot less value. Oh, I have some problems. Let's just do 2 then. Doesn't matter. So there's now differences in the way that they work. So if we go in here now, and we can then say, because you know the bird is an animal, so if we say b dot eat and then 4, okay, then 4, we can see when we do this eat, we can see that it goes to here, right? If bird is not a bird but an animal instead, it will first check to see if there is an eat method on the animal, and it will find that it's an abstract method, so it has to go to the concrete class to find out how to do it. So I can actually define, instead of defining bird as a bird, I can define it as an animal. Oops. Oh, sorry. No. I'm screwing around here. No, I can define it as an animal, but create a new bird. Of course, I cannot instantiate animal. And then I add that bird, and then I can say b.eat. So it actually sees b as an animal here. So if I say b.eat, it can find it, not because it's on the bird, but because it's on the animal. So it will go to the animal and see it's an abstract method, and then it will jump into the bird and do eat like birds eat, like 50 times the value kind of way of doing that. Yeah. So this is basically abstract classes. So the way that they differ from regular classes and interfaces is that it's actually a mix of both of them. So a regular class cannot have abstract methods. So if we go first thing, a regular class can be instantiated. We can say new and then the name of the class. We cannot instantiate an abstract class. And the reason is it can have abstract methods, and that means it would not know what to do in that situation. Next difference is that inside of the abstract class itself, we can have abstract methods, meaning we can define a method to be made by the subclasses. So for this case, every subclass of animal needs to be able to eat, and it needs to do it in this specific way. And this is basically what we can do with abstract classes. So it's a pretty cool way of defining these kind of what can you call them, like templates for methods that you can use at a later point in time. It also makes your code a bit more complicated, so you should be a bit careful with this, but sometimes it can also make your code a lot less depending on each other. I won't go into details in this video because this should be short. I'm not good at that, but I'll try. But definitely, there's a lot of good use cases for abstract classes and interfaces and creating nice little structures like that. So So the next natural step is to look into some software design patterns. So if you look into those, you will see that interfaces and abstract classes are some of the ways of building systems where you can change things in the system without affecting all classes at the same time. So this is what we call coupling and cohesion. We want every class to be independent as possible from other classes, and be able to change important parts of the system without needing to change everything in the system for every little change that we have. Something also called shotgun surgery. That's it with abstract classes and overloaded methods.